The Younger Dryas Impact Hypothesis, Prospects for a Physics-Based Model. In 2006, Richard Firestone and Alan West wrote a book entitled The Cycle of Cosmic Catastrophes, How a Stone Age Comet Changed the Course of World Culture. The next year, Firestone and 25 co-authors published a paper entitled Evidence for an Extraterrestrial Impact 12,900 Years Ago that Contributed to the Megafaunal Extinctions and the Younger Dryas Cooling in the prestigious journal Proceedings of the National Academy of Sciences. The paper proposed that one or more large, low-density extraterrestrial objects exploded over northern North America. The ideas presented in the book and in this paper came to be called the Younger Dryas Impact Hypothesis. The publication in a scientific journal subjected the ideas to the scrutiny of the scientific community, including physicists and impact experts. Firestone wrote another paper in 2009 admitting that the publication in the scientific journal had unleashed an avalanche of controversy, and he repeated his claim that the evidence for the extraterrestrial impact consisted of magnetic microspherules, carbon spherules, nanodiamonds, and glass-like carbon. In addition, Firestone's 2009 paper suggested that the orientation of the Carolina Bays was caused by the shock wave of the extraterrestrial impact around the Great Lakes or Hudson Bay. The Carolina Bays had only been mentioned as the source of some impact proxies in the 2007 publication, but the 2009 paper proposed them as evidence supporting the extraterrestrial impact. In 2011, 7 impact experts wrote that Firestone's papers had not shown shock metamorphism and other expected markers of an extraterrestrial impact. The authors said that some of the impact processes defied the laws of physics. In addition, the microspherules and nanodiamonds submitted as evidence of the extraterrestrial impact were seen as contrary evidence rather than as supporting evidence. In conclusion, the physical evidence presented by Firestone was largely rejected by the scientific community. In 2012, Mark Boslow and 15 co-authors published their objections to the Younger Dryas Impact event. The authors mentioned that there were several versions of the Younger Dryas Impact Hypothesis and that they differed in significant details. The main objection was that the fragmentation and explosion mechanisms did not conserve energy or momentum and that the hypothesis did not have a physics-based model. Evidence against the airburst proposed by Firestone's 2007 paper appeared in 2013 with the publication of a large platinum anomaly in the Greenland ice sheet at the Younger Dryas boundary approximately 12,900 years ago. Although the paper provided reliable evidence that an extraterrestrial impact had occurred at the Younger Dryas boundary, the authors proposed that the projectile was an iron meteorite of high platinum content that was unlikely to result in an airburst. What is the physics-based model that the critics keep talking about? A physics-based model is a numerical model that computes the motions of objects by physical simulation. The model applies the laws of physics to calculate the deformations and the distribution of matter resulting from aerodynamic friction, collision, and cratering, making sure that the total energy and momentum are conserved. This slide has some equations of energy conservation from the book by Professor J. Melosh. The book by Professor Melosh has an example of the application of the hydrodynamic equations that govern impact cratering to the numerical simulation of the meteor crater impact published in 1961. Modern computers make it possible to use numerical hydrocodes to solve simulations of nuclear explosions and extraterrestrial impacts. In 2013, James Whitkey and 27 other collaborators quantified the amount of microspherules attributed to extraterrestrial airbursts or impacts by a fragmented comet or asteroid. This investigation examined spherular geochemistry and the process of spherular formation. The authors estimated that 10 million tons of spherules from a cosmic impact were distributed across 50 million square kilometers. The authors stated that the results are consistent with melting of sediments to temperatures greater than 2,200 degrees Celsius by the thermal radiation and air shock produced by passage of an extraterrestrial object through the atmosphere. Mark Boslow and 3 co-authors sent a letter to the Proceedings of the National Academy of Sciences repeating the criticism that the impact hypothesis did not have a physics-based model and that the arguments presented in Whitke's paper demonstrated a misunderstanding of comets as well as the physics of airbursts. In 2018, Wendy Wolbach published 2 papers about the biomass burning triggered by the Younger Dryas cosmic impact. The first paper about ice cores and glaciers had 26 co-authors. The second paper about lake, marine, and terrestrial sediments had 30 co-authors. Since these papers were published just this year, the opponents have not had time to criticize the paper by stating that the burning could just have been the result of forest fires rather than the effect of a cosmic impact, and that the Younger Dryas cooling could have been a typical ice age phenomenon rather than the result of soot and dust in the atmosphere. In summary, the prospects for a physics-based model are not good for the Younger Dryas Impact Hypothesis. Thus far, no impact crater has been found. No shock metamorphism or meteorite fragments have been presented. The airburst hypothesis is precluded by the platinum anomaly. The microspherules and smoke particles could have a non-impact origin. The nanodiamonds have been challenged, and the quantification of spherules does not provide the basis for a physics-based model. Proponents of the Younger Dryas Impact Hypothesis, like Firestone, originally included the Carolina Bays as an effect of the extraterrestrial impact. The idea was abandoned when many bay features showed different dates of formation. It was only in 2017, with the introduction of the Glacier ice impact hypothesis, that the elliptical geometry of the Carolina Bays led to the conclusion that the bays were conic sections that originated as inclined conical cavities from the secondary impacts of glacier ice ejected by an extraterrestrial impact on the Laurentide ice sheet. The Glacier ice impact hypothesis offers a path toward a physics-based model. The conic sections of the Carolina Bays and the convergence of their major axes by the Great Lakes provide the initial conditions for the model. The bay geometry provides launch and impact angles. Ballistic equations using the distance between the convergence point and the base provide the speed, height, and flight time of the trajectories. Yield equations correlating energy with crater size provide the mass and volume of the glacier ice projectiles. The energy of the extraterrestrial impact can be estimated by combining the information from all the bays using the laws of energy conservation. The big question is whether the proponents of the Younger Dryas Impact Hypothesis are willing to reclaim the Carolina Bays as a way of building a physics-based model.